I will share my screen. There we go. All right, so thank you everyone for joining us. This should be interesting. So this has kind of become a bit of a DevDays tradition over the years. One of the very first sessions we tend to do is a session on HAPI and how HAPI works and a little bit of history and all of that. And we'll usually do a more advanced session on HAPI a little bit later in the program. And we're kind of sticking to all of that. We are changing it up a little bit, just taking advantage of the virtual format. So I'll get into how that's going to work in just a second in terms of what we're doing there. So a little bit of background, who I am. That's my face. Back in the days where I wore collared shirts and not just lounge stuff all day. Who knows when we'll be back to that. I have been leading the HAPI project for 15, 16 years now, since nearly the start of that project. And have been involved with HAPI since basically the beginning of that project. My day job these days, I am the head geek and CTO of a company called Smile CDR, which sells a commercial version and consulting services around FHIR services and HAPI and all that good stuff. So that's me. These slides, incidentally, are Creative Commons licensed. We in the FHIR community feel very strongly about open collaboration, open content, free exchange of information, all those good things. I've got a link here that you can use to grab a copy of these slides, but don't worry if you don't have time right this second. I am going to close by leaving this link on the screen for longer, so you'll have lots of opportunity to grab that afterwards. So in terms of how we're structuring this, I've got 3 sessions over the course of DevDays. You're at the first of 3. Tomorrow from 2:45 to 3:45, we've got a Let's Build session. I've also got an office hours section towards the end of Tuesday. Which of course is also tomorrow. Today, what we're going to do is just a whirlwind tour of HAPI features. We're going to talk about how the parser works, how the client works, how the facade server works, and how our storage engine, the JPA server, works. So we'll talk about each of those things, as we often do in introductions. But more interestingly, what I'm going to do is I've got sort of little intro exercises for each of those parts of the library. Obviously, there's no obligation that you even look at those exercises if you don't want to. But what I'm hoping is if this is your first introduction to HAPI, or at least you're fairly sort of new to the process, or there's a part of the library you haven't played with before that you'd like to try playing with, there are these little exercises you can use to get going on them. And really the reason I think that's interesting is that at tomorrow's session, of course, we'll talk about those exercises. And if you've got questions about them, you'll have a chance to get answers to those things. But we're going to dive into some more advanced features for the Let's Build session tomorrow, primarily focusing on the interceptor framework, the new interceptor framework in HAPI. We're going to look at how security works, and that includes neat concepts like authorization, authentication, consent management, all that good stuff. We'll also talk a little bit about partitioning and multi-tenancy, which is a brand new feature in HAPI 5 that was released a little under a month ago. And we're going to have exercises for you to start playing on with all of those features. These exercises are standalone, so certainly don't worry if you don't have time to do the stuff for today. It's not going to hinder you tomorrow, not at all, but you may end up finding the tomorrow stuff building on what you did today if you do. So that would be excellent. And of course, if you've got any questions about any of this stuff that you don't get answered today or tomorrow during the session, feel free to drop by the office hours. It'll be interesting to see how that works in a virtual format. I think that'll be kind of fun. So, oops, let me change slides. There we go. So HAPI itself has been around since 2001. I joined the project maybe 2 years later, so I wasn't around at the very start of the HAPI project. But it was originally started as an HL7 version 2 library, and to this day we do maintain that V2 library. It's one of those rare examples, I think, of software just plain being finished. So we release a new version these days probably every 4 years. And generally speaking, we're releasing it to fix 1 or 2 bugs, and that's about it. There's not a lot of active development going on, which doesn't mean it's not a good library anymore. It's used in tons of production systems. We personally use it in production systems we build today, but it doesn't get a lot of new feature requests because it's kind of a legacy code base at this point. In 2013, we started HAPI, which was intended to be sort of a companion library to the HAPI library, but for what was then brand new emerging FHIR standard. We have tried really hard to sort of build these projects, both of them, as sort of modular sort of little granular sort of bits of library that you can pick and choose from and take the pieces you need from, skip the parts you don't. Anyone in the Java ecosystem who's familiar with the Spring framework, and everybody either loves or hates the Spring framework in the world of Java developers. One of the things that I've always loved about Spring is that you can pick a single class in that library and get a bunch of value from it, even if you don't need the rest of the framework. But of course, if you need parts of the rest of the framework or the entire rest of the many parts of that framework they all fit together really well. We've tried very hard to sort of take that same ethos with HAPI, so it is intended to be useful in lots of ways. We believe very strongly in sort of reuse of code and all of that stuff, and free use of code. And hence we are licensed under the Apache license, which does of course mean that even if you're building commercial software, even if you're selling software that includes HAPI, you are 100% free to do that. There's no royalties, there's no telling anybody, there's no opening up your own source code or anything like that. Apache is a very permissive license, and we believe very strongly in that. I will say, just because some people get confused by this a little bit with the names, HAPI, the V2 library, and HAPI, the library, are separate. There is no sort of connection between the two, other than the fact that they fall under the same umbrella of projects. So a quick real whirlwind tour of what the parts of the HAPI library is here. First off, we have defined a set of model classes which sort of model all of the parts of the FHIR standard. And this really covers all of the versions of FHIR that we support. So the patient resource, for example, we've got a class called patient.java, the string data type. We've got a class called stringtype.java. And really the entire rest of the library. So this nice set of models that represents everything that is FHIR. And in fact, there are models for every version of FHIR as well. We no longer support DSTU1, but we do support DSTU2, 3, 4, and even the current drafts of 5. So there are models for all of those in the current release of HAPI, and they can be used. They can be used in a single application, in fact. So it's possible to support multiple versions of FHIR from within your application, which is neat. We've got parser serializers, so you can transform those models into stringified versions, whether you're serializing in JSON or in XML. There are tons and tons of features in those parsers. I'll talk a little bit about that in a moment. There is a client framework, of course, allowing your application to go and talk to servers out in the cloud somewhere. And then built on top of that is an Android-specific client framework that is completely tailored to the needs of Android applications. And then in the server side of the house, we have got what we call the plain server framework, which is sort of that's more commonly known as a facade. This is the idea that you've got an existing storage model and you want to bolt a FHIR server on top of it. That was actually use case number 1 for HAPI. And then we've got the JPA server framework, which is our storage engine. So that's like a FHIR server in a box. These incidentally, the stuff in green is what I'm going to talk about really quickly today. There are a number of other parts of the system that I'm not going to cover here, even though they are super interesting. And those would be great candidates to come to the office hours and talk about if you wanted to chat about them. Most importantly, the validator. We're not doing a session on the HAPI validator this year, but it is an ever sort of changing topic in HAPI, and has actually gained quite a bit of functionality in the last year. So kind of an interesting one. There are, of course, narrative generators. There's the web testing UI, which is you'll know it as the UI that you actually see when you go to hapi.phir.org. You can put that into your own system if you want that same UI for yourself. And of course, our CLI tool, which is effectively a server in a box, and then a whole bunch of other goodies packed in there as well. So to start out with working with the model, HAPI, as I said, has resource classes and type classes for basically the entire data model that is FHIR. I won't dwell on it too much, but it is very good stuff. For a given version of FHIR, there will be a patient class, as I mentioned, and as you can see from this diagram, they will inherit from a different package structure depending on the version that you're using. That's a good thing because it means you can have multiple versions of FHIR in a single application, as I say, so that can be quite useful. There is a super interface called iBase resource, which every one of the resource classes extends. And you can you'll find iBase resource in places like the client. You'll find that it's super omnipresent just because most of the client methods will use iBase resource to avoid being locked into a single version of FHIR. We've also got data types. So FHIR, of course, defines a set of what it calls primitive data types. Those are all the things that you would expect a language to have, Booleans and strings and decimal numbers and all that good stuff. You'll recognize those in our data model as being classes that have the name of what they are and they'll end with type. So string type and decimal type and Boolean type, that type of thing. FHIR also defines a set of, they call them general purpose types. Just because I'm an HL7v2 person, I always call them mistakenly composite types. Same kind of thing. A composite type, of course, is a little structure that has a few fields that are grouped together for some purpose. The human name example I've got up is a great one. Obviously, there are human names in lots of parts of the standard that include a last name and a first name and I don't know, a prefix and a suffix and all that stuff. Those general purpose types as well are represented in Java. We just don't end them with the word type because they're little structures. So human name, quantity is another example of that. Contact point is another example. So those are, all of those data types have their own Java classes that they work with. I will show you a little bit of code here. This is our very first look at HAPI FHIR code and how it works. You'll find this stuff hopefully very easy to understand, especially with this nice color scheme that we've got in this slide. What we're doing here, of course, is creating a new resource instance. And to do that, just as with anything Java, you will call the constructor to instantiate that object. The thing that I always do like to point out is we've tried really hard to sort of use this method of doing API design where we call it fluent design. And fluent is basically everything is intended to be chained together. And the entire HAPI FHIR library uses this like crazy. I find it great just because it tends to lead to very readable code. You can do things like call add name, and then you'll say set family, add given, and you can sort of see that with a single call, we can chain all this stuff together and very quickly build up the information that we need. Add identifier, same kind of thing. We'll set a system and a value on it. And generally speaking, you'll sort of chain everything together in a single line, which is, it does tend to lend itself to really nice readable code, which is great. There are enumerated types for lots of things. Of course, in FHIR, we tend to codify lots of stuff. You know, if you're building a patient resource, you're going to have to deal with a gender. If you're dealing with, you know, things like contact points, which are phone numbers and that type of thing, you have to say what type of contact point it is. For any of these what FHIR calls coded fields with closed bindings, we will create an enum, a Java enum, and we'll use that. You're not required to use it, of course. There are methods, there are overloaded methods on the models that let you pass in the equivalent strings if you want, but the enums can be quite pleasant as you're developing against this API, which is nice. Worth pointing out, and I guess this builds on what I just said, all of the primitive types in FHIR are really wrappers around a native Java concept as well as a string representation of that concept. We do that for a couple of reasons, which I'll talk about here. For the most part, if you're dealing with something like a Boolean, you really don't care about the string true. You actually care about the Java concept of true and false, of course, because you're going to do Boolean logic on that type of thing. So in that case, it kind of makes sense that you would never interact with the string representation. There are other spots though where things work a little bit differently, and decimal is kind of a nice example of that. Of course, for a decimal number, you can deal with the 1.2, you know, the native Java representation of that. But there are cases in FHIR where numbers of significant figures actually matter, and I'm showing an example here with a whole bunch of trailing zeros. That string representation is preserved in the decimal type, and this is one of the reasons that we have these wrapper types, is to allow you to do this type of thing. So if you have a use case that involves leading or trailing zeros and you don't want to lose those, these wrapper types can be quite useful to you. They are sort of abstracted away in many spots. I think I cut out that slide which showed it, but I will mention that for the most part, when you work with the resources, if you don't need to, you're not even required to look at these things like the Boolean type. You know, for example, on the patient class, there is a method that's just called getActive, and it returns an underlying Java Boolean. So if you want to know the active status of a patient, which is a field in the patient resource, you can just call getActive. You don't need to be interacting with the Boolean type at all. But there are also methods that will allow you to interact with those things. So getting into how you use these things, we'll talk a little bit about the parser next. I'll introduce the concept of the HAPI context object. This is a class called FHIR context. It is ubiquitous within the HAPI library. It's the one thing you just can't get away from touching, no matter what you're doing and what version of FHIR you're dealing with. The context class is effectively a factory for the whole rest of the library. So you'll create one of these contexts, you assign a version of FHIR to it, and then you'll tell it, I'd like you to give me a parser or a client or a validator or a localizer or whatever part of the library you need to interact with. And it gives you all of those things. Worth mentioning, and this is like the biggest gotcha of HAPI probably, the context is a bit of an expensive object to create. It has a little bit of a startup time while it boots up. It is entirely thread safe though. It doesn't leak memory, it doesn't leak threads, it doesn't leak anything. So the best practice of all for using HAPI is create one of these context objects once when your application starts, and then just keep it for the, the life cycle of your application. And don't worry about the threading implications or anything like that. The library is designed for that type of use, which is good. So a simple example of how to use a parser in HAPI I'm showing here. Of course, I'm creating a patient resource, I'm assigning it a bunch of values. And then what I'll do is I'll ask for a context object, and I'll ask that context object for a parser object. And the parser has all kinds of configuration, but I'm going to give it the most useful of all configuration, which is to ask it to pretty print. Pretty printing, of course, is that nice indentation so that we're not just seeing a really condensed blob of JSON that is unreadable. And what that gives me out is a string representation of what I've asked for. And running that, here's the output of that. And as we can see, we've got all of the nice details I had stuffed into that resource being returned to me as a string, which is nice. So that's the parser. I'm now going to move on to clients for a little bit. And incidentally, I did skip parsing strings from strings into data models just for time, but I will say that you can do that with those parsers as well. So that does support going both directions. Clients in HAPI, as with many things in HAPI, we've grown the library organically, and there are several ways of creating clients in HAPI, and several actually entire mini frameworks for clients in HAPI. And they all have they have their own purposes. The two that we'll talk about here are the annotation client and the generic fluent client. I've got code examples of both of them up on the screen. The annotation client, which is on the left, you'll recognize it as looking somewhat similar in approach to frameworks like JAX-RS or Spring REST or Easy REST or any of those, REST Easy rather, any of those things. You'll recognize it because it's using these annotations, you're creating interfaces with annotations, and the framework will give you a client which sort of implements whatever annotation you've annotated client class you've created. This was actually the first of the two clients we created. It remains fully supported. It's often used, and I use it myself a fair bit. But what we're going to focus on today is actually the one on the right, the generic fluent client, just because it's a bit of a lower barrier to entry. And my honest opinion is it's a little bit nicer to use. So it's usually my first choice. The fluent client is intended to be a little bit less statically typed. So it's a bit more of a dynamic thing, which has all of the pluses and all of the minuses of that. But I will say the generic client is certainly the more popular of the two. So it's probably a better starting point. So a simple example of how to use the fluent client I'm showing here. I am creating a patient as always. I'm not showing actually populating the fields in there just for space, but of course for this to be a useful example, we would set some values on that patient object first. We will ask the context, or we will create a context object rather. And importantly, you always have to specify what version of FHIR you're creating a context for. So we're creating an R4 context here. I'll give it the base URL for a FHIR server. Oh, and I should really update this slide because this FHIRtest.uhn.ca is down and does not want to come back to life right now. But the equivalent would say hapi.phir.org here. That server is up and working fine. So that would be a more realistic example. With that base URL, we call this method on the context called new RESTful generic client, which gives us a client object. And then we use the client to actually do stuff. The client supports all kinds of different operations. I'm only showing one example here, which is how to do a create, and I'll talk in a moment about some other things than create you can do with the client. But the thing that Be point out is that to build anything with the client, the nicest thing you could do is bring it into an IDE, type client dot, and you'll be presented with an IntelliSense, an autocomplete menu in your IDE that will give you create and update and read and history and transaction, all of the usual things in FHIR you'd ever want to do. They'll all just pop up in your IDE, which is nice. The thing to note is every single client call with a generic client will always end with .execute. That's the end of the chain, and that's the method that actually causes the thing to get invoked. Another little gotcha that people sometimes run into with this API is they'll get as far as client.create.resource and then leave it at that, and nothing will happen. And that's because they didn't add .execute to the end of their statement, which meant that nothing happens. So make sure not to do that. So running this, what I'll get back from the server is I've just printed out what it's returned to me, which is I've just created that resource. Here's the ID I granted it, which in this case is 1, 2, 3, 4, 5. Worth mentioning, the return type for many of the operations in the HAPI client, not all of them, there are some where it's more appropriate for it to be something different, but many of the operations in HAPI FHIR will return a method outcome object. And that method outcome object has all kinds of good stuff in it. You can pull back the resource and ID and the location, like the full URL, which are generally called from the location header. If the server responded with a body of some sort, you'll have that. If the server responded with an operation outcome resource, you'll have that. So whatever the server replied with, you'll get those details out of the method outcomes. There's lots of good stuff that you get back. Searching, and we really only have time to scratch the surface of searching here, but it is such a cool feature in this library. I'm showing one really neat example where we're doing all kinds of neat FHIR things here. This is a search for resource patient, where the patient's name matches a value of test and the patient's birth date is before this day. We're saying, I want you to give me a count of 100, and this is kind of a requirement of the thing. You tell it what type of what typed bundle you want to get back. And then you say .execute, and we have returned back this nice bundle, which has all of the search results for what we just asked for. I realize you wouldn't be able to just type this completely by making it up. You do need to sort of figure out what the syntax is, but I do find it really readable, which is nice. And there are tons of examples of this on the website for how to do this. So as I say, that was the most whirlwind tour of the HAPI FHIR client library imaginable. The FHIR REST framework in general is incredibly rich, goes in all kinds of directions. There's all these different operations like history and the capabilities operation, transactions, batch operations, deletes. And then there's all these weird nifty sort of niche features that are in there, like version aware updates and create if not exist, get if newer, all these awesome things. And any of those you can absolutely, any of that is supported in the HAPI FHIR library. I'm going to bounce out of these slides for just 1 second and take you to the HAPI FHIR website, which is at hapifhir.io. And I'm going to click on the documentation. And I do this just to point out this client section here. If you would like to find an example of how to do anything with the HAPI FHIR client, here's a search example, but whatever it is you want to do, here's a conditional create if we wanted to know how to do conditional creates. Whatever the thing is that you'd like to do, there are absolutely examples of it on this generic Fluent client page in the docs here. So certainly get to know those, they're pretty good. And I will also point out this URL is wrong. It used to be right. I need to update that slide. I'm gonna do that as soon as we're done here. So let's change gears from clients to talk about servers. And awesome, just in where I wanted to be in terms of time. That's great. There are 3 server frameworks in HAPI-FHIR worth talking about. The first is the plain server. The plain server is all around HAPI-FHIR providing is all around you providing a storage engine, and then HAPI-FHIR providing the rest stuff, the glue that sits on top of it that supplies you with a nice HTTP server on top of things. This is often called a facade, and this pattern is fully supported by FHIR. Whatever, this is anyone who ever asks, I've got a file system with stuff I want to serve up, or I want to stick a FHIR server on top of my Hadoop instance. The plain server is your go-to for that. The JPA server is our relational database storage engine. So if you're not trying to stick a FHIR server on top of an existing product, but in fact you just want a complete ready-to-go FHIR server, the JPA server is your friend there. And I'll talk in just a second about how to use that. I will mention we've also got a server framework built on JAX-RS. This is useful for people who are already using JAX-RS and just want FHIR capabilities in the mix. It's not nearly as full featured, so I will say, unless you have really good reason, probably the plain server is a better starting point than the JAX-RS is. But there is good stuff in there. We're not going to talk about JAX-RS today, though. So the plain server is effectively, as I say, a complete implementation of FHIR's REST specification in Java. It is built around servlet technologies, so you can deploy your code into all of the usual containers like Tomcat and Glassfish and JBoss and all of that. It is inspired by many of the popular REST frameworks out there, but is not using those REST frameworks. This is sort of, for whatever reason, a very common sort of challenge people run into and end up on our mailing list. They sort of assume that we're using Spring REST, and they try and just drop HAPI-FHIR into the middle of a Spring MVC project. We are not a Spring MVC project or a JAX-RS project or any of those things. It is an independent framework. So while we absolutely can be used with those frameworks, you do have to do some work to sort of set up the glue between any of the existing REST frameworks and HAPI-FHIR. The way the whole thing works is you write basically user code that implements the individual FHIR operations you want to support. So if you're writing a server that's going to support read and create and update, you're going to write methods that implement those, and they're probably going to return our model, like they're going to return a patient resource or a list of patient resources or an operation outcome, depending on the specific use case. And you're going to give those methods specific annotations, which I'll show you in just a second. And the framework takes care of all the rest. It scans those annotations. It'll fire up an HTTP server. It will parse URLs and resource bodies that come in and serialize the response, all that good stuff. The idea here is that you are writing the storage logic, regardless of what your storage logic looks like. It could be, you might be just serving up data from memory. You might be talking to a relational database of your own design, or a vendor product that you're just trying to bolt FHIR on top of for a vendor that doesn't support FHIR. You might be talking to a NoSQL database or a file system, or even an Excel spreadsheet. I've seen all of these examples as things people have done. So whatever it is, you're writing code that does that storage bit, and then the HAPI framework is taking care of all of the rest. All of this stuff gets wired together. You're creating these classes called resource providers. One of these classes per resource type you're going to end up writing. So a typical implementation, let's say you're writing a FHIR server that's going to support let's say the patient resource and the encounter resource and the observation resource. If you've got those 3 resources to support, you're going to create 3 what we call resource provider classes, one for each of your resource types. And then you're going to create one other class that's called the server class, which will extend a class called RESTful server. And that's sort of used to wire all that stuff together. If this diagram doesn't make intuitive sense to you, don't worry. We do have I've got a ready to go example that shows all this stuff that I'll take you to right at the end today. As I say, at the very end, once you've got this stuff all sort of wired together, you can build a WAR file and deploy it to a container. This is pretty traditional stuff. You can package it up, put it into Tomcat, put it into Jetty, put it into WebSphere if you want. That all works. You certainly can use embedded containers as well. And I will say these days, this is my preferred approach actually, is just to write an application that includes a server and bundles up Jetty, which is my favorite of the Java app servers. And you can kind of just wire all that stuff together in your application and not worry about deploying more files out to servers, which I think is kind of a nice way to do that. So as I say, when you're writing one of these servers, really what you're doing is creating these things called resource providers. A resource provider implements an interface called iResource Provider. And the iResource Provider really doesn't tell you to do much. All it requires is this one method called getResourceType, which I'm showing here. And that just indicates what is the actual FHIR resource type that this provider is implementing. I'm not showing here any examples of actual implementation code, but I think I will in the next slide. Yeah, there we go. Here are some examples. If I wanted to create a read operation, so this is, just get a resource by its ID. This is the rough signature for it. If I'm supporting a create, this is the rough signature, and you'll notice for create, we're taking in a raw body. So this is an actual patient resource that we're going to store in a database or do whatever it is we're going to do. Here's an example for search, and this is a search that's supporting two parameters, the family and the given. So this is a search by name. And this again is just scratching the surface of what can be done with this API. You may be thinking, how do I know what these annotations are and what the signature should look like? That's a pretty good question. We've even got the correct link on this this slide. So the good thing here is that all of the ways of doing these things are all documented on the website. Once again, where the page that I'm at is under plain server. I'm in this REST operations overview, and you'll notice here tons and tons of examples. So if I want to know how to do a read, this is how that works. If I want to know how to do an update, or let's jump to something random. If I want to know how to work with tags, for example, here's the way that I do that. So all of the different operations you would ever want to do, there are just tons and tons of examples in here for all of those things, which is great. Oops. So that sort of covers all of that. With all of that said, so this is, oh, you know what, I'm a little bit early, so I have left myself with a bonus slide, and I'm going to cover it right now. That's awesome. One final thought before I get onto the exercise, and the wrap up for this session. I will mention that HAPI's release cycle currently is, we do 4 releases a year. We do them quarterly, although our quarters are a little bit weird. We do them in February, May, August, and November. So May, we've just had our May release. The next one will be in August. The next after that is November. We do maintain an extensive change log. I'll click on that for a second to show you. This is all the stuff that's coming up in August for 5.1.0, but all of the details about what's in HAPI FHIR 5 are all here. There is just tons and tons of detail about all of that, which is good. The other thing I will draw your attention to is this other page in our documentation. If you're ever wondering about support for individual versions of FHIR, with relation to versions of HAPI FHIR, this page can be really useful just because it sort of shows the relationship between those two things, which is good. So HAPI FHIR 5, our current version, as you can see, no longer supports DST1, but still does support 2, the weird so-called 2.1, 3, 4, and this is the specific release, draft release of 5 that we're supporting there. So that's quite useful. And then finally, so this is where I'm going to close things. I'll close things here by saying, I'm going to leave this on. So if you wanted to take a screenshot or whatever of the slides that you have the URL, this is a good time to do it. Link here is to these slides. We've also got exercises ready to go for working with the client, working with the plain server, and working with JPA. If you click on any of these bit.ly links, you'll be taken to the link before it. And these are ready to go examples of how to build those things. For the first two, I've added a little exercise that you'll find that right in the README markdown file that is sitting right inside there. The JPA server doesn't have so much of an exercise because just getting it going is a bit of an exercise. But looking at its README, there's all kinds of stuff in there. Really what you'll want to do there is out of the box, it's using a database called H2, which is a nice embedded Java database, but there are instructions there for hooking it up to MySQL, hooking it up to Postgres, hooking it up to Oracle, whatever the storage engine is you want. So tons and tons of opportunity there to get that stuff going. And I guess because I have time, I'll click on one of these just to show you. So this is the starter project, and as you see, a bunch of tasks and steps you can use to go through to try this stuff out. So that is everything I wanted to talk about today. And if I'm not mistaken, I've got 5 minutes left. So we are as on time as I could possibly have hoped for, which is awesome. So we've got 5 minutes for questions if anyone wants to ask any right now.
Great, James. It's Elliot. We've actually got a bunch of questions that came in while you were talking. The first is from Alex, and it's wondering what the relationship between the two HAPI projects are at github.com/James Agnew and github.com/HAPI.
Great. So the deal there is everything that so HAPI these days, well, I guess let's say this, HAPI started out as being a single monolithic GitHub repo. That's the repo under my personal namespace, James Agnew. As the library grew, we kind of realized that monolith just wasn't a very good sustainable way of building such an extensive library. So we've been slowly breaking it up into individual sub projects. As we break pieces of the library out into their own modules, we're one by one moving them into HAPI, into the HAPI namespace. So that's the main deal there, is that anything that still lives under my namespace is just stuff we haven't broken up yet, and we will eventually be moving everything over.
And if I can actually build on that, if you wanted to get involved with contributing code, doing something like that, how do you go about getting involved?
Oh, amazing. So this is a common question. I will say oddly enough, we've just passed, what is the number now? We've got probably hundreds of people have contributed code to the library over the years. And we very much welcome outside contributions in terms of developers. If you're interested in working on something in HAPI, the place we recommend you go is to our Google group, which you'll find a link to right from our website. There's a link right up at the top here under Get Help. There's our Google group. If you go up in there and just ask a question, post, I'm interested in getting involved in the library. We're always happy to help people either find a thing to work on or just walk them through what the process is if they've got something they're interested in working on. And we do very much appreciate all the outside help we can get.
Great. We've got another question here from Julia. Do you see any benefits to having multiple HAPI APIs which serve different resources as opposed to one server handling all resources?
Oh yeah, this is fun. So, I mean, ultimately, that's very much a
come back tomorrow for the next session.
Yeah, we will talk a little bit about that during tomorrow's session. I'll say the short version there of the answer to that is ultimately, if you've got a single server serving everything up, that of course is an easier API for your end users because the FHIR spec itself is kind of designed as a monolith. It makes all kinds of assumptions that you've got a single endpoint serving all your resource types. So it's nice for your end users. Of course, architecturally, it's much more difficult because this means you've got one monolith, sort of single point of failure. Whereas if you've built a microservice set where individual resources are their own endpoints, you've obviously got a more maintainable system. The best of both worlds is to have a bunch of separate HAPI servers doing separate resource types, but some sort of proxy in front of them, an Nginx instance or something like that, that effectively hides the fact that these are separate servers. More and more, I'm seeing people take that approach, and I love it. I think that's kind of the best possible approach because it gets the best of both of those things.
Great. Somewhat related, how do you handle cross-resource searches in HAPI as a facade model?
Yeah, there's where things get difficult. I mean, I will say that is a thing that HAPI, unfortunately, like it's not going to give you an out-of-the-box solution to that. I have seen people absolutely solve that problem by building a facade that is doing its own orchestration. You might think of this in terms of, if I had a whiteboard, this would be much easier. But think about maybe I've got a server that's serving up my patient resources, another HAPI server that's serving up my observation resources, and a third HAPI server that sits in front of those two, still speaks FHIR and delegates down to the bottom two layers, depending on what's going on. That is a fairly popular model for doing that. And in fact, we even built one of those within our Smile CDR commercial product that does exactly that. Of course, that's not the focus of today. It's pretty easy to build one of those things just using the REST framework that sits on top.
Okay. And does the GPA server support multi-database tenants?
Oh
Multiple
yeah,
database,
absolutely.
multi-tenant. Sorry.
So I'm glad you asked. Up until our May release, the answer to that was no. As of May, the answer to that is finally yes. I'm not going to say any more about it, only because there is information here. Actually, I've got up on the screen. You can see this partitioning and multi-tenancy. This is the section of the docs that talks about this. But I'm going to give you a demo of how this all works and a little architectural run through of it all tomorrow during tomorrow's session. So come back tomorrow for more details on that.
And we are actually out of time.
Great. Well, thank you all.
James,
Hopefully
thank
I'll
you.
plug tomorrow.
Thank you, everyone.